Hello students, in this part I will be commencing with the type of questions that can be framed from this quiz chapter. So I will be dealing with the first two parts, which are solving the trigonometric equations by factorization, and the second part is by introduction of auxiliary argument. In the first part I will be treating a trigonometric equation as an algebraic quadratic equation, and then I will be finding the solution, and in the second part I will be considering the equation as a algebraic equation again, and I will be solving it by substitution method. So let's start. So now we are going to have a look at the road map, that is what we have covered till now and what we are about to cover. So first we had unit circle, we had the description of the general solution, the trigonometric equations and their solutions. Then we had the concept of unit circle, in which we found that in various quadrants the trigonometric ratios have various polarities, as in first quadrant has all the trigonometric ratios as positive, the second has sine and cosec as positive, the third one has cosec, tan and cot as positive, and the fourth one cos and sec as positive. Then we learned various multiples of pi by 2 in addition to the unknown angle. Then how would I proceed with the changing the transformation of the trigonometric ratios, and then in multiples of pi in addition to the unknown angle, then how would I change the trigonometric ratio, will it change or not, and what would happen to the sign. Then we learned those concepts. Then we found out for general solution, we learned how to find out the general solution, what would be the basic angle, the principal angle, and then we found how the various formulae that were there involved in finding the general solution in various forms, that is sin theta is equal to 0, sin theta being equal to 1, cos theta being equal to -1, cos theta being equal to 1. Then we had sin theta is equal to sin alpha, and for tan and cos also. Then we had a look at sin square theta is equal to sin square alpha, and same was for cos theta and tan theta also. Then we had simultaneous equations, that is sin theta is equal to sin alpha and cos theta is equal to cos alpha. Then how would we proceed? So those were such concepts involved in the general solution. Then we had a look at the principal argument, that's the principal angle, and what it basically means, where would it lie, what's the range, how do we find it, was learned by the basic algorithm for finding the principal argument or the principal angle or the principal solution, sometimes we call it. Now what we are about to learn is the types of questions that can be framed from this chapter. So I'll teach you about how various formats in which these questions come, and how in what way can the questions be framed. Then we'll have some examples based on those types. Then at the end I'll have trigonometric inequalities we'll be dealing with. And so type 1 is the trigonometric equation by factorization, that is in the quadratic form. So suppose if I have a trigonometric equation in the quadratic form, where the variable is either the cos square x or sin square x, so the trigonometric ratio is itself a variable. So if I have the quadratic equation in such a form, I can solve by using the quadratic formula or by factorization. So it has to be in quadratic form for that. So the basic thing here is factorization. Now we'll find a general solution for 3 cos square x minus tan cos x plus 3 is equal to 0. Let's see, I'll try to factorize it. 3 cos square x minus 9 cos x minus cos x plus 3 is equal to 0. That gives me 3 cos x taken common. That leaves me with cos x minus 3 minus 1 taken common. That gives me cos x minus 3 equal to 0. Now cos x minus 3 is taken as common and leaves me with 3 cos x minus 1 is equal to 0. So cos x will have two values, either equal to 3 or 1 by 3. So 3 can be rejected as cos x lies between 1 and minus 1. Hence the value for the base angle of x, base value would be cos inverse 1 by 3, and my general solution would be x is equal to 2n pi plus minus cos inverse 1 by 3. And this would be the solution and the general solution to this equation. Moving on to the next type now. The next type is the trigonometric equation, solving the trigonometric equations by introducing an auxiliary argument. What's an auxiliary argument? It's an imaginary argument we have just supposed to simplify our calculations. So suppose if there is a form of equation, that is a cos theta plus b sin theta plus c is equal to 0 is equal to c, then we'll assume a as r cos theta, r cos phi, and b as r sin phi, where r is equal to root over a square plus b square and phi is tan inverse of b by a. So the equation would become r cos phi cos theta plus r sin phi sin theta is equal to c. If r taken is common, r is taken common from this equation from the left hand side, that would become cos phi cos theta plus sin phi sin theta, which is of the form of cos theta minus phi, which would be equal to c, and cos theta minus phi would be equal to c over r, which can be assumed. Now this is the auxiliary argument beta, which I have assumed to be cos beta. Why cos? Because on the left hand side I have cos itself. So I would try to put it in a standard form, that is cos theta is equal to cos alpha. That's why I have put it cos beta on the right hand side equal to c by r. C by r has been replaced with cos beta to get cos theta minus phi is equal to cos beta. Now theta minus phi would be then equal to 2n pi plus minus beta, and theta would then be equal to 2n pi plus phi, phi being transposed to the other side would become theta equal to 2n pi plus phi plus minus beta, where beta is equal to cos inverse of c over r, where beta can be written as cos inverse of c over r. Now let's see, I'll take an example. If I have sec x minus 1 is equal to root 2 minus 1 tan x, so I'll try to solve it using the same form. Root 2 minus 1, let's say it is sin x over cos x, and sec x can be written again as 1 over cos x. So my solution to this equation would become, I would transpose this 1 to the other side and take all the trigonometric ratios on one side. So I would get 1 minus root 2 minus 1 sin x is equal to cos x, which would then again be giving me cos x plus root 2 minus 1 sin x equal to 1. The coefficient here is, I would like to show you how it was done in the example. The coefficient here is 1 and here is root 2 minus 1. So I took the value of r as root over a square plus b square, which would be here taken as 1 square plus root 2 minus 1 square. That would give me 2 plus 1 plus minus 2 root 2, that is 3 minus 2 root 2 plus 1, that is 4 minus 2 root 2. So r here would be 4 minus 2 root 2. So I would write 1 as r cos phi, when phi is tan inverse of b by a, that is root 2 minus 1 over 1. So coming back to the question now, I have 1 being written as 4 minus 2 root 2 cos phi plus root 2 minus 1 being written as 4 minus 2 root 2 sin phi. The first one in multiplication with cos x and second one in multiplication with sin x shall be equal to 1. Then 4 minus 2 root 2 is taken as common. I will be left with cos of x minus phi being equal to 1, and I will have cos of x minus phi equal to 1 over 4 minus 2 root 2, which I am here assuming as cos beta. So I will get x minus phi equal to 2n pi plus minus beta, and x is equal to 2n pi plus minus beta plus phi. Now I would replace beta and phi in terms of the original variables that I had. That would give me x is equal to 2n pi plus minus beta can be written as cos inverse of 1 over 4 minus 2 root 2 plus phi can be written as tan inverse of root 2 minus 1. That will be my solution. Moving on to the next type then. But before that, let's have a fact, maths for thought. Do you know what's a Pascal triangle? Pascal triangle is basically a triangle consisting of, now this is a Pascal triangle. So this was the apex, that was 1 divided into 2, then it was again divided into 2 such that here I got 1, then the number in the middle was an addition of the two numbers above it, and here as there was no number here, hence it was 1 transferred here. So and so on, I got 1 from here, then 2 from here, so it got 3. So the numbers are 1 11, 1 2 1, 1 3 3 1, 1 4 6 4 1, and so on. But if I see that, aren't these 11 raised to n pattern? So if I come back to Pascal triangle, it consists of number where each entry is the sum of two entries above it. So, but this is also a quick way to generate 11 raised to n, as the reason being, the mathematics behind that is, it is of the form of x plus y raised to n. So if I see here, 11 is 10 plus 1 raised to n, and here I have 11, hence it is the sum of the coefficients. It is the coefficients of the binomial 10 plus 1 raised to n, and hence that's why I get 11 raised to n in pattern in the Pascal triangle. So students, in this part we learned the first two types of questions that can be framed. The first one by factorization and the second one by introduction of an auxiliary argument. In the next part, we will be solving the next two types, which involve conversion of the trigonometric equations, which are of the form of sum of trigonometric ratios, and then converting them to product form, and then product to sum form. So keep watching.